Interesting to see what happens when I start recording. What happens to my my mining? Okay. So let's go ahead and look at the assignment that all of you did. Oh, this is the one. This is the one that was assigned on Friday. It's due today. Yeah, my computer's actually really working hard right now. The fan's blowing. Is it keeping up? Okay. So, these were the productions you had to implement for. We already had it working for the first two. So the code I provided already had this functioning for the first two. You had to have it working for a second production of an if statement. Okay? You had to have it working for a production of the for loop and the while loop. Let's do the for loop and the while loop first, then deal with the second production of the if statement. Okay? Because I think the second production of the if statement is actually the most difficult part of this. All right. So we'll go into our code. The syntax for the for loop is for, open parenthesis, semicolon, semicolon, closing parenthesis, single statement. Okay? So here's our match statement for that. This is our first production. This is our second production for an if. Then we have our else, return false, whatever. But now let's do an else if. We're looking at a for. If we're looking at a for, what should happen next? We should match the opening parenthesis, this guy, then the semicolon, then the semicolon, then the closing parenthesis. So first thing we'll do is we'll print out the for. Then match opening parenthesis. That's what this guy does. Then match semicolon. That's what this guy does. Match another semicolon. That's what that guy does. Match the closing parenthesis. That's what that guy does. And finally, after we get our closing parenthesis, we need to match a statement. How do we match a statement? By calling this dot match statement, passing in our lexpass. Finally return true. So that's how we add the production for the for loop. Not bad, right? Okay, what about the while loop? While is the word while, open parenthesis, close parenthesis, statement. Pretty much identical to the if statement. So we'll match the while, put out the while, match the opening, match the closing, match the statement. Return true. Okay. So that's how we would do this for all the productions except for the if that also has the matching else. Oh, actually, we need to do a do while. Smaller font. Okay. Yeah, the do while is actually a little bit interesting. For the do while, we're going to match do, then we're going to match a statement, then we're going to match the while, open, close parentheses, semicolon. So if we match a do, what will we do? We'll print out the do, then we'll call this dot match statement, lexpes. Then let's see what's it. Then we'll match our while. So I'll keep this part here. Get rid of the rest of this. So now we match the word while. Pop it, print it. Then we match the opening parenthesis, pop it, print it. Then we match the closing parenthesis, pop it, print it. Then we match the semicolon. Pop it, print it. That make sense? So that's how we would match do-while loops. So that one's a little bit different pattern, but we're still utilizing our match statement just in the middle there. And then we're using our lexpes, which is a fancy name for a stack, to match the other parts of it. Again, assuming our syntax is always correct. Okay? So now, before we do anything else, why don't we go ahead and go into our source code. And let's edit this a little bit to include some of our new productions. So we'll put a for in here. Then we'll put a do. And the do, we'll put nothing inside the do. That's our do while. Well, actually here, inside the do while, we'll put a while. Okay. So we handled the for, we have a while, we have a do while. Okay, so all the productions we've added, we now have examples of in here. Go ahead and save that. We'll run this. And we see right here, we're matching our for, opening parenthesis, semicolon, semicolon, closing parenthesis, opening, close. Then we have our while. Actually, opening, and then we have another opening. Is that how we wrote that? Opening. Oh, we do have another opening, but we didn't write out the do. Which probably means this. Probably means we did not add do to our reserved words. Let's go to our language reference. So we get into the for, opening curly brace, then we should print out a do. Do we make sure we print it inside the do? Maybe, actually, I think that's probably what I did not do. Well, I should print it right here. For, opening, closing. And inside the for, we had an opening, so we matched that right there. But then we should have hit a do and matched that. which it seems like we did, but we didn't. So we have the opening curly brace, we have the while, opening, close, opening, close. Then we have our final while associated with the do. Open, close. Looks like we did not catch the well, here's this close, and then we get the semicolon. I read a couple of those things out of order. So we must be pushing and popping from our stack funny.
What I was thinking is like when you go you end like curly brace, that would like be basically level.
Well, it shouldn't. Pushing it onto the oh, so our add isn't actually a push. Okay, so if I go into LexPez, specifically added to the front. Is that the only place we're pushing it back on? Well, it read the end of the while loop correctly. Why is it not reading the do? There's for, opening, semicolon, semicolon, closing, opening. It's right to here. And then it's missing the do. It's getting the next opening. Gets the while, open, close, gets those. Closes the do, so it matches that. Then it gets the while, open, close, semicolon. Then close, close. While ends right here, so this is this close and this close. And this close. It's missing one last closing. Let's make sure this is syntactically correct code I've written here. This is a beginning of a statement. This is a statement with an opening. Corresponding closing is here. So what's inside of here should be a statement. Well, it is a statement. That's that. That's a collection of 0 more statements. Here's an if, followed by a statement. Here's an if, followed by a statement. First statement here is a for, followed by a statement. Here's a do, followed by a statement. Here's a while, followed by a statement. This closes this statement. And then the while ends right here. This closes that statement. This closes that statement. All of this whole if, was the one big statement associated with this if. This closes this outer if, and then this closes the source code. Yeah, I think our syntax is correct here. just quickly. I'm just going to print out here whenever I match a do. Okay, we're never actually matching a do. That's part of the issue. So just real quickly, let's make sure that we're getting our tokens separated correctly. Yeah, we never get a do. Why the heck not? Okay. I mean, that's in our Lex tokens. We're never actually getting a do read in. The do should be right here before this one. Anybody else have this issue where they weren't reading in a do, or did you not test it with a do? Here, just for the sake of sanity here. Just match a simple, that's the whole syntax there. Make sure we read in a do now. Okay, so our I'm just going to print out, as we're classifying each of our tokens, I'm just going to display that. Let's just make sure we're at least tokenizing do. No, we're not even tokenizing it, okay? Somewhere before that, we are losing our do, Simon. All right. So we don't even have it here. So I feel that we're probably correctly lexically identifying do's, but we never actually read in do's. Process statement. We call process statement first. Right here. Read it in one line at a time. As long as the line exists, we call tokenized string. Here's tokenized string. Just quickly. Make sure we at least read in the string that has do in it. I don't know why we would not. Not yet. No, because I didn't even write the if with the else in it yet. So it's not in my source code, and it's not in my it's not compatible with our language yet. Okay, so it is reading in the do. And after we trim it, it should still be there. We should just have a bunch of no extra spacing, okay? So we have the do. Let's see how it handles do. Is S's length 0? No. Otherwise, it's our special array. We have our potential matches, current token. Not going to be inside the special character array. That's fine. So we'll do cur token plus equals s.char at I. We should see it build up a D and an O in here. Okay, so it got the do. We should see the do right here print out. Or does it never hit that? So here's our array. Do will be nowhere in there. Potential matches should then be 0. We found no things in there for the D. So we'll go ahead and tag D onto our current token. Print out cur token. We see the D, then the DO. Okay, good. So we get the D, we get the DO. Then we hit the end of the line because we trimmed it. So we'll fall out of this for loop. Which should put us right here. Oh, this is the end of the for loop, right? This else matches this. That matches that else. This must match that for. Okay, so when I get right here, if I were to print out cur token, I should see do there. But I'm not doing anything with it. So I need to be able to handle that if something is still if we're out here past our for loop, right here, and something's still inside of cur token, we need to add it. Because the problem is, I think our code currently assumes that cur token's been emptied out and everything's been added up to this point. But if we finish processing it doesn't even make sense. Why would we ever end our for loop here? Oh, we assume every single line is going to have a special character on it. We assume, right now our check says add it to our list of tokens as soon as we hit one of these guys. That's the end of our current token. In this particular case, when we read in the line that just says do, we never hit a special character. So we're building up the token, which we do. We eventually want to add it to our subtokens. We never get in here for this guy. We never get in here for this guy. Actually, hold on. If I is equal to, this will be the last time through, even if there are no so this is going to say if we are at the last character in our string and we would have hit that already. So we got the O. Next time through is when we failed. Okay, this is where we would have thought we were catching it, but we're not. This says if we've run out of things in our string and we didn't do anything with it, then go ahead and add it. We're going to steal this line here. Make sure nothing is left in cur token. If cur token dot length is greater than 0, add cur token, set cur token equal to the empty string, which shouldn't make a difference because this method's now over. We're inside of this else. That should make sure do gets added onto our list. So now when we print out just the Lex tokens, we get the do. Which means now, when we match the tokens, we get our do. Okay, it's properly matching it now. So our whole problem was when we originally conceived our language and we wrote the tokenizer, we didn't consider that we'd ever have something like a do on a line by itself without any special characters to let us know we were at the end of a token. So we just had to throw something, a catch-all out there. So now, if I go back in here, oh, you probably didn't want to do that, because, okay. Well, whatever. The problem we were having before is it wasn't picking up the do. All right, so now we need to handle the if-else, correct? So I think this handles all of our productions except the situation where we have two separate ways of if statements. We have an if followed by an opening parenthesis, followed by a closing parenthesis, followed by a statement. But we potentially could then read in an else. That make sense? So what we need to do is we need to go into the if, the code we currently have written for the if. This is where we're matching in our statement. All right. Now what we need to do is we need to go ahead and try to match an else, because there may be an else there. We also might be at the end of this guy, so we need to be prepared to put it back. Okay, so we're going to try to match an else. How are we going to do that? We're going to go ahead and grab the next guy off the stack. Actually, we need to probably do it this way, because potentially this could be the end of the code. So I need to say string temp is equal to lp dot pop. And just as a reminder, does pop sometimes give us a null? It does. So pop will give us a null if we're out of stuff. Okay? So now we'll ask if temp is not equal to null. We need to check to see if it's a else. So if temp dot, now we need to say parts. Just check peek real quick. No, that won't work. Okay. So we'll go ahead and get our parts, except we're not going to get it from pop, we're going to get it from temp. Because now we know temp holds something real. So we'll go ahead and decompose our token, having the result inside of parts. Then we'll ask the question if parts at bucket 0 dot equals, here, I'm actually just going to steal this. If we're looking at an else, what do? We print it, and then we match the statement. Does that make sense? So if we just found an else, we'll go ahead and print out the else, and then our production says, for the if that has an else, it's an if, open parenthesis, close parenthesis statement, followed by an else, followed by a statement. So we'll match the else, print out the else, then match our statement, ultimately returning true. Otherwise, if I'm in here, that means that I popped something off the stack, it was not an else. I'm not in the if that also has an else. Therefore, what do I need to do? I need to put it back, so that the next guy has the opportunity to work with it. So if that's the case, then I'll say lp dot push temp. The guy we popped off the stack, we'll put him back onto the stack. But if we popped off a null, we have nothing to put back on because we didn't actually take anything off. This make sense? So this should now allow us to match. We'll just expand on our code a little bit. So we have the do, let's just throw inside of here, if so there's an if and there's an if else. We should be able to match both of those here. Ruh-roh. Hold on, first let me get the here out of there. I want to say this was the same problem as we had with the do, but the the solution we came up with should have fixed it for the else as well. Hold on a second. I'm just looking for my here. I want to delete that before I forget about it. No, it's going to be... Oh, there it is. There's my if. Oh, hold on. Oh. We haven't added else. It detected it as a symbol or as an identifier. So inside of our language reference, we're going to see that we do not have else loaded in here. We put it in there. Now our language supports else's. Make sense? Okay, so that should be the full working version of our homework. What we're going to do when we come back next time, well, I could open up Keynote, but just for the sake of argument here, we're going to need to start handling some of our other productions, like dealing with types and things like that. Also, right now, notice we're completely ignoring this idea of Boolean expressions and math expressions and things like that to make these simple. But hopefully what we saw from this assignment was what we did in class was write the first two productions. That is, we matched for a standard statement, opening, closing, curly braces, and we matched for a simple if. We saw that adding the additional productions was mostly cut and paste, right? We had to go back and fix our little tokenizer issue there, which is one line of code, but the after we hunted it down, but the adding those productions once we can trust our tokenizer is quite easy, isn't it? Can't we almost add anything to our language now? At least at that top level, without getting into processing Boolean expressions and things like that. All right, questions, comments, concerns, bribes. All right, I'll see everybody on Wednesday. No. The only thing I added in here, all I added is this. That just says if there's something still stuck inside of cur token, add it. No men left behind.
That's what I got stuck on. That's the wild
The while or the do while?
Just the while.
Okay, here's the while. The while should be identical to the if statement.
Okay.
Except you're matching the word while instead of if. Like literally every line of code here should be identical.
Just the same as
It's
minus that whenever we add
the if before we add any else.
So if we had put do,
Like if you look at this matches the while, so we print it out. Then match the opening parenthesis, pop, print. Match the closing parenthesis, pop, print. Then match the statement. And if is the exact same thing. Match the if, match the opening parenthesis, match the closing parenthesis, match the statement.
so before we fixed our tokenized string with the like if statement of the 2 lines, if we had had like in our like notepad or whatever,
Yeah.
if we had had do curly bracket and then the line would have worked. Or is that's okay. It doesn't work here. At least it doesn't have anything else.
Oh. If we, I see what you're saying. If we would have done this. If we would have done that, yes. It would have caught it.
Watched 2 episodes of Game of Thrones. That was a bad idea. I couldn't figure out why I wasn't detecting.
But it's actually an interesting problem, isn't it?
Yeah.
Because we actually had to, it was something we had trusted. We had to go back and find the bug.
I thought it was a language from the color out, and then like when I was
Yeah.
like,
No, we're
That is never possible.